Hi guys, we're going to look at arithmetic sequences today. So a sequence is any list of numbers, but it has to follow a pattern or a rule. So each number in our sequence is what we call a term. So here's an example. We start at 1, 3, 5, 7, 9. We go up by 2 every time. Keeps going on forever. So like 1 is a term, 7 is a term, 3, 5, 9 are all different terms in this particular sequence. Okay, 2, 4, 8, 16, 32. That's also a sequence. It has a rule. We're multiplying by 2 every time. Okay, again, every single one of those terms, every single one of those numbers is a term. 64 would be our next number. That's also a term. Okay, we're going to look specifically at arithmetic sequences, which means between our two terms, you're always going to be able to add or subtract the same number. That number that you add or subtract every single time is called the common difference. The common difference, we denote that with a lowercase d. So when you see a lowercase d with arithmetic sequences, that's asking for that common difference. So here we're going to look at a sequence and we're going to ask ourselves if it's arithmetic. And if it is, we have to figure out what is that common difference. So it's 7, 12, 17, 22. Obviously we're going up, so are we adding the same number every time? And yes, we are. So yes, it's arithmetic, and our common difference would be 5 because we're adding 5 to every number. Okay, you guys tell me if this one is arithmetic, and if it is, tell me the common difference. All right, so just a little information for these arithmetic sequences. We're going to use lowercase a for arithmetic. A sub 1 is going to represent our first term. A sub 2 then is our second. You can assume A sub 3 would then be our third, and so on. Every sequence has a different number of terms, so we generalize that as A sub n. And n would be our nth term. So in one example, n might be 7, and we'd be looking at our 7th term. But in another example, n might be 92, and we'd look at the 92nd term. Okay, I'm going to introduce what we call a recursive formula. So this is going to be an equation that's going to help us find our next term. So we have a sub n, remember that's any term, equals a sub n minus 1 means the term right before. So this means the previous term. So we're going to take the previous term plus our common difference to get the term we're looking for. So again, I define these. A sub 1 we know as our first term, d we decided was our common difference, and n is the term number you're looking for. It's really important to know that the recursive formula, so this formula right here, in order to find your next term, you have to have the previous term. So we'll do a couple examples that are going to help us understand what that formula is all about. So we'll go back to that example that we said was arithmetic. So we have 7, 12, 17, and 22. Just to get some of that terminology, a sub 1 was our first term, which is 7. A sub 2, the second term is 12. Third term is 17. Fourth term would be 22. Fifth term is 27, and so on. Okay, so our goal now is to write a recursive formula and then use that formula to find the 6th term. Well, the nice thing about a recursive formula, this is what we just defined. These two pieces are always going to stay the same. Every single example will have a sub n equals a sub n minus 1. The only thing that's going to change is that common difference. So we said our common difference was d equals 5. So we're going to plug that into that equation. So our recursive formula is a sub n equals a sub n minus 1 plus 5. Okay, now, so we did the recursive formula. Now we need to find the 6th term. Well, in order to find the 6th term, that means our n value is going to be 6. So I go ahead and plug that into our recursive formula. So a sub 6 equals a sub 6 minus 1 plus 5. Okay, remember, I just took n equals 6 and plugged it in for both of my n's. That's how I got to this step. Well, I know that 6 minus 1 is 5. So this is a sub 6 equals a sub 5 plus 5. Well, if you remember from our notes, a sub 5 means the 5th term. Well, we don't know the fifth term. The last term we know is the fourth term. So I need to find my fifth term. Well, to find my fifth term, I take my fourth term plus 5. Okay, so 22 plus 5 gives me my fifth term is 27. So now a sub 5 we know is 27. We're going to plug that in for a sub 5. Remember, that's helping us find our sixth term. So our sixth term is our fifth term, which was 27, plus 5 more, which is 32. Okay, since 6 isn't very far off, we could have said 7, 12, 17, 22. Fifth term is 27. Sixth term is 32. Okay. All right, here is another example. 10, 7, 4. Ask yourselves, is this arithmetic? Well, we seem to be subtracting the same constant every time. We're subtracting 3. So our goal is to write the recursive formula and then find the seventh term. So our common difference we said was -3. So our recursive formula looks like this. Remember, these two pieces will always be there. And then we just change our common difference. And then our seventh term, I just started listing them. So we knew 10, 7, 4, subtract 3 more, 3 more, 3 more, 3 more. And then I labeled them. 10 is our first term, second term, third term, fourth term, fifth term, sixth term. Here's the seventh term, which is what we were looking for. So a sub 7 is equal to -8. All right, here we go. Last one. Here is a sequence. I want you guys to tell me what's the common difference. And then I want you also to give me the next 3 terms.